Hi, and welcome to my talk on stability of democracies. The political scientist Yasha Monk wrote in 2016 that even the best trained scholars of political science assume that extreme events are not going to happen. Now, of course, Yasha Monk is not naive or ignorant. It is just clear that extreme events are very difficult to predict, and part of the reason is that they are very rare. The former head of the Axel Springer Publications Company said in 1979 that he sees no reason to regard the quotes around the country acronym DDR as obsolete. And all of his publications set quotes around this acronym to indicate that they believe in the German reunification. And they wouldn't stop doing this for another 10 years. If we fast forward to 1989, this is a newspaper announcement from August 1989, where suddenly the Springer Publication Company announces that they would stop using quotes around the acronym DDR for East Germany. And you can see this as somewhat of a giving up. So German reunification is likely not going to happen anytime soon. August 1989. We all know what happened just 3 months later. The wall fell and the two Germanys were reunited, and just a year later the DDR ceased to exist. This is an extreme example, of course, of a political event, a breakdown of a system, but it illustrates how hard it is to predict these events. Then I want to bring your attention to a slightly different kind of political transition. It's called democratic backsliding. What I'm showing you here are data from The Economist. Their research unit, the Economist Intelligence Unit, has devised an index of democratic health. And I've picked out a few countries here where the data are given from 2006 to 2016. You can see Norway has a steady increase in democratic health. 10 is the maximum of this index. 0 is the minimum and indicates there's no democratic properties left anymore. So North Korea is not surprisingly very close to that minimum. The three countries I picked in between, USA, Poland, and Hungary, have as you can see, a slow decline in their democratic health. This is what is called backsliding, because these countries are considered to be consolidated democracies, not on the transition towards a democracy, but they show this backsliding in their democratic index. And just to give you an example, in the case of Poland, the European Commission has filed a lawsuit against Poland for breaching basic rules of democratic state because the independence of court is not quite guaranteed anymore. And there are other examples like that. This backsliding, according to the political scientists Wiesner and Lust, is lacking theories. So they write, we lack theories to explain backsliding. Although political scientists haven't been lazy, they have been worked a lot on democratic transitions. So, of course, very much from non-democratic states to democratic states, but also the reverse, although more of the sudden breakdowns of democracies and much less so on backsliding. In my talk, I want to answer the following questions. First of all, I want to tell you why democracy is a complex system and really explain to you what is complex and how that applies to democracy. And once those concepts are in place, I want to discuss the question of how can understanding democracy as a complex system help us understand the instabilities of democracy. And I want to really go towards applications of these ideas and tell you about policy implications that we have worked out in a team of scientists that we can draw from understanding democracy as a complex system. And of course, the overarching theme is how can democracy be studied with the help of computational social science. And I'll give you a few examples from non-democratic complex systems that indicate how this can be done. And the hope, or rather the future work that I'm engaging in, is to apply those techniques to democratic systems. Okay, what I'm telling you about is not just my own work. Instead, it's been done by a whole team, very interdisciplinary. So I'll show you here the different disciplines that have been involved. I myself am positioned between physics and maths. And we met in 2018, so a bit over 2 years ago, in Bristol. The results I'll tell you about today are the outcome of discussions on that meeting and also follow-up online discussions that we've had. The main message of our work is that if we realize that democracy is a complex system, and if we understand the right notion of stability, the notion that is appropriate in the context of democracy, then we can begin to study instability in democracy, and we can also begin to use the computational and mathematical tools that we have in complexity science to study instability in democracy. So let me begin by asking which notion of stability is the right one in democracy. And we all know in different disciplines, the term stability or robustness has different meanings. So one of the exercises that we did as a group was asking, what's the notion of stability in your discipline? Let's begin with computer science. Seems appropriate. Here, a notion of stability is the following. An algorithm is robust of its performance, if its performance, is not altered substantially when slight modifications are made to its experience. So really what we want is the output of the program not to be substantially different when the input is just slightly different. Okay? The next notion of stability that's more of a physics notion is the idea that the macroscopic realization of a system can slightly change, but the macroscopic state of the system should not massively change if there's a slight change in macroscopic conditions. And that's, of course, there's situations where this breaks down, but in an equilibrium system, this is the case. And this is the notion of statistical mechanics, where the macroscopic state of this computer, for example, is massively changing just because there's a bit of heat moving the molecules around. Both of these are rather static notions of stability or robustness. The next notion is more of a dynamic one. A system is resilient if its structure or dynamic are stable in the presence of perturbations. And the fourth one is also dynamic, and it's related to this one. It is about a system being resilient if it has the capacity to adapt its behavior while maintaining function. So the difference between these two, I'll illustrate that on the next slide. Here's a cartoon to explain these two notions of stability, or resilience would be the term that's often used in this context. We have a system, which is a black ball, and it's situated in an environment which here is a landscape or potential. Now, a slight perturbation to that system would be a push to the left or to the right, which makes this ball slightly oscillate, but eventually calming down again and sitting back in that equilibrium. Whether it is able to do that depends on the shape of this landscape. So if that landscape changes dramatically to, for example, this one, a slight push of the system will actually push it out of that state into a new one. Okay? And we would distinguish between a high resilience state where a slight push is not going to change the state of the system to a low resilience system where a slight push is going to change the state of the system into a new one. And the fourth notion of stability that I just showed you, which is the adaptation, can be seen as the situation here on the lower right side, where really what the system is doing is it's adapting its state or its behavior to a new one, which in the face of this perturbation is bringing it actually into a state which is more resilient. I will now show you 4 examples of complex systems that do undergo a transition. They are a glassy material, a stem cell, a climate system, and the economy. So let's begin with the glassy system that I show you on this slide. The transition from a liquid to a glass is certainly a state transition, because we know liquid is liquid and a glass is solid. But actually it's not a proper phase transition in the sense that a physicist would consider a transition. If you were to watch, so while this material is solidifying, which means while the temperature is dropping, if you were to watch this under a microscope, you can actually not see, just from looking at where the molecules are and how they're moving, that there is a transition from one to the other. And this is, ongoing research on this is still very much ongoing. And we use tools from information theory to identify the point where and when the solidification starts to happen. And this is basically, the main element in this analysis is a correlation function, a dynamic correlation function, which is based on the mutual information that you see here. This allowed us to identify a transition regime, if you like, where the system is beginning to go from liquid to solid. The next example has a clearer point of transition, and yet still difficult to identify. The example is that of a stem cell. Stem cells, as we know, when they are triggered, they differentiate to a somatic cell. So the data that we used here are those of blood cells. And we know that once a stem cell is differentiated, it cannot go back. But actually the point of no return is not clear to molecular biologists. So what we did is we used information theory once again, and we measured the Shannon entropy of the expression of these genes. And the data are the dots here, and the x-axis is time. And what we saw is that there is a clear spike in Shannon entropy around the point where the transition is expected to be. So here is, again, this is a rather simple mathematical tool, and it helps to understand transitions in a system which is quite complex, the stem cell. And it was single molecular spectroscopy that made the data collection possible. The third example I want to show you is that of a climate system. The onset of the monsoon is a clear transition in state from a very dry period to a very wet period. And the example here is in India. Monsoon is a terribly important event, and millions of people's livelihood depend on it. So predicting its onset is actually very desirable. People from the Potsdam Institute for Climate Impact Research took data of the near surface air temperature, and they analyzed these data using the tools that I showed you in the beginning in this cartoon landscape. And what they were able to do is to actually fit, if you like, a landscape of that nature. And when a system is coming close to the edge of this manifold, if you like, and it's about to fall down, so it's about to go from one state dry to another state wet, then that's known in physics and math. The fluctuations of the system will increase a lot. So what they did is they measured the fluctuations of the near surface air temperature, and indeed they were able to predict the onset of the monsoon within an accuracy of a few days, which is quite extraordinary. It's even more extraordinary when you think about how complex the system is, and that here you can really reduce it to just a few relevant parameters. And that is not unusual in complex systems. The fourth and last example I want to show you is that of the economy. Here I show you data from house prices of houses sold in the United States. The data were analyzed by the team of Jo, who is an economist, and Sonette, who is physicist turned economist. What they did is they used the mathematics of physical phase transitions to analyze these data, and basically they fit a phase transition equation to it, where they could predict the point of divergence of this curve, and that would be the critical point where, according to this analysis, the bubble would burst. So the house prices would explode. A singular point. They predicted the singular point to be mid-2006. This was published in the beginning of 2006. And we now know that this prediction was actually quite a good one. The bubble actually burst in 2008. And we know that it triggered a whole financial crisis which affected most countries in the world. So now let me get back to democracy as a complex system. I've given you 4 examples of complex systems just now. So we had a material, we had a stem cell, we had the climate, and we had the economy. And now I want to tell you why, in what way, democracy is a complex system. So let me begin by telling you a bit more about what is actually complexity and what is a complex system. This question has interested me for many years, and I have been discussing this question with my colleague James Lageman, who is a philosopher of science, for over a decade now, believe it or not. And the results of this discussion is now finally coming out as a book with Yale University Press. 5th of August is the publication date. This book answers a variety of questions. So one question that it answers is there such a phenomenon as complexity, or is complexity really just a summary for complicated and difficult to predict? And we answer this question with a resounding yes, there is such a thing as complexity. It is an actual physical phenomenon. Other questions that we're asking and answering are: what makes a system complex? What features of complexity are there? Are all complex systems the same, or do they have different features? And also, what tools exist, mathematical and computational tools, and how these tools are related to the features of complexity. Out of this book, I pick a figure here. And this figure summarizes the features of complexity. So what you see on the outside here are features that we would consider necessary conditions for complexity. So we have numerosity, which is just that there are many elements and, very important, many interactions between these elements. We have disorder. These systems are never static. There is noise in them, and they're never perfectly ordered. They are not in equilibrium, and they are always exposed to an environment, to influence from the outside. We have feedback, very crucial for generating structure, and diversity. I'll come back to that. Is similar to disorder, but not exactly the same. And then on the next ring here, the middle ring, we have the emergent phenomena of complexity. So I want to pick out in particular self-organization, which encapsulates the phenomena of complexity, because there is never a single controlling element in a complex system that determines the dynamic of that system or the structure of that system. Instead, order and organization is arising from the many interactions between the parts, and it's spontaneous and not controlled. And in the center, we have some more properties that are held by systems that are functional. So those include, of course, the living systems, but we don't distinguish between functional and living in this context. Now, what about democracy then? How does democracy fit into this view of features of complexity? What I'll do now is I'll pick out a few of these features, and I'll tell you in what way they are related to democracy, and in particular in what way they help stabilize democracy, before I move on to in what way democracy can be destabilized. So let's start with disorder. Here's a quote by the historian David Runciman from Cambridge University. "The randomness of democracy protects us against getting stuck with truly bad ideas. It means that nothing will last for long, because something else will come along to disrupt it. This is a bit like the thermal noise in physical and biological systems. It seems a nuisance, but actually it's crucial to get unstuck from undesirable states and to generate new structure. Next, I want to comment on feedback. This is a quote by political scientists Page and Gillens. The health of democracy and the extent of economic inequality have tended to rise and fall together. So what they're saying is that really, if democracy increases, then economic equality also increases, and vice versa when economic equality decreases, so inequality is rising, the health of democracy is suffering. So here we have a reinforcing phenomenon. Feedback can come in two colors. It can be reinforcing and it can be stabilizing. The third property I want to pick out is diversity. This is a quote by political scientist Henry Farrell and statistician Cosmo Schelisi, who write that some degree of diversity and partisan disagreement is healthy for democracy and even necessary. They did a mathematical model of this, in fact, to show in what way disagreement is helping to find solutions to problems that would not have been found if there was only homogeneity in the system. So we have three examples here that help stabilize a democratic system. We have disorder as something to generate solutions to problems and to stabilize a structure, to repair, if you like, also. We have feedback, which can be stabilizing. So economic equality would be a stabilizing factor for democracy because they're reinforcing each other. It can also be destabilizing, and I'll get to that on the next slide. And diversity is a form of heterogeneity, which helps the system find new states. That's a form of adaptation, if you like, to a changing environment. So what about destabilizing factors? Here I'll point to something, I'll point to the non-equilibrium, and I begin with showing you this feedback loop that I already mentioned, economic inequality. And then in what way does that actually destabilize the democratic health of the system is that when the economy is very unequal, so wealth is very unequally distributed, then the influence on political institutions is also unequally distributed. So those with more economic resources will have the ability to, for example, lobby for certain law changes that then in turn will benefit them economically. So that's a reinforcing feedback loop which destabilizes the system. Now, it turns out that, this is again a rather common phenomenon, is when the system is then exhibited to a shock from the outside. And an example, of course, is the financial crisis, or financial crises in general. Then that can, where the system initially was maybe able to maintain a somewhat destable state, but yet it was able to stay there. With a shock, then the system can actually be kicked out of its equilibrium into another one, and that might not be a desirable one. Feedback, I want to comment on that a bit more. Another form of feedback which can be destabilizing, and we see a lot of that at the moment, and we did see that during Trump election and Brexit referendum, is the interactions between the media, the audiences, so those who consume the media, and political actors. And that can lead to, we know what false information, we hear a lot of this on this conference, I'm sure, has the effect of reinforcing, so false information can reinforce itself if this loop is not disrupted, which is what we're trying to do with bringing in fact checkers and so on. So out of these aspects of features of democracy as a complex system, what we wanted to do as a group was to take a step towards the real world and ask, so what? what can we learn from looking at democracy as a complex system and from identifying these particular features as being stabilizing or destabilizing. So we came up with a set of policy recommendations where 3 of them are top-down and 3 of them are bottom-up. Let me begin with the top-down policy recommendations that we came up with. The first one we call entrenched diversity by regulation. And there are quite a few examples out in the real world already that realize that diversity is important for the health of democracy. Citizen assemblies is one such example, and in the European context, Ireland has done a lot in that direction. So, for example, Ireland has had several referenda over the last years, one on abortion, legalization of abortion, and one on introducing same-sex marriage. So very controversial topics. And they brought together groups of citizens with, randomly picked people, but not entirely random, because they wanted to have a good representation of age, gender, location, and other parameters. They brought together these groups of between 50 and 100 people, gave them lots of information on this subject, then gave them ample time to discuss and come up with a recommendation. This recommendation was then written down with a comment and an explanation of who gave this recommendation, how it came about. And that was then sent as leaflets to all households in Ireland. And the impact of this measure on the actual vote, that's ongoing research, but it's quite certain that it did have an impact. And the outcome of the referenda was that abortion was legalized and same-sex marriage was introduced. Monitoring feedback. We've seen that feedback is a positive property, but it can also have destabilizing. We saw destabilizing examples. And one way of monitoring feedback in the political system is, for example, limiting political spending and making it transparent, which some European countries have that entrenched in their constitutions. Germany is one such example. And the third top-down policy recommendation is ensuring connectivity. And this conference is full of examples where especially social media illustrate how connectivity is not ensured and how ideas sit in one corner of that network and do not get challenged from other corners. Right? I'll give you 3 other brief examples of entrenching diversity. And also, they're also part of connecting up citizens with each other. So these policy recommendations are not mutually exclusive or independent of each other. So just briefly, Korea has a system of soliciting opinions from citizens on very specific topics. Uncrewed vehicles is one such topic. Madrid has a similar thing in place where they solicit opinions from citizens. Everyone can participate and voice their opinion on specific measures that the council is wanting to take. And Iceland is maybe more familiar to you as a very in-depth and sophisticated system of asking people for their views that then actually influence the policy. That's an important bit. Bottom-up recommendations. First one is recruiting credible communicators in estranged regions of the network. So this one is probably best explained by example. The prison system in the United States, mostly Democratic politicians were pretty much in agreement that it needs reforming, but the more Republican side of the spectrum didn't see that need. Instead, they rather wanted to make it harsher. Until a group of Republicans that actually themselves had been imprisoned for tax fraud and similar things, they raised their voice and started advocating the reforming of the prison system because they had actually been inside and seen what's happening. So that's an example of credible communicators, which are the Republicans that then advocate for something in their region of the network. Recognizing the limits to message control, very much a topic of social networks, which people here know a lot about. And there's more detail in the paper. And emphasizing the difficulty of forecasting. So thinking you know what's happening in a month's time is not understanding the limits to your forecasting. Okay, I'll stop here. There are these two papers. I put them up on Pathable, so you can download the PDFs there. There's more information on these projects and other work I do on my website, and I thank you very much for your attention.